Hey guys, welcome to Unit 3. This is 3.1. We're just going to get a good definition of functions. Then we will go on to graphing functions, quadratic functions, and kind of memorizing what the graph of y equals x squared looks like, y equals the square root of x looks like, things like that. No, I wasn't really going anywhere with that sentence. All right, so to define a function, we need to first define what a relation is. Does that look straight? All right. A relation is a correspondence between two sets. Set X is called the domain and set Y is called the range. I'm going to give a few more names to the domain and the range. So if it is X, it is the domain. That is very important, okay? If it's Y, it's the range. If it is the X, it is also the input. If it's the Y, it's the output. If it's the X, it's the independent variable. If it's the Y, it's the dependent variable. Or a dependent set. And it's just like dependent because it's dependent on X. We decide what X is, and then Y depends on what we decided X was. So I say X is the first, and Y is the second set. The way I remember it is that X comes before Y in the alphabet, D comes before R in the alphabet, and I comes before O in the alphabet. First comes before second. Good? So alphabetically, X is the domain because X is before Y and D is before R. Input comes before your output. Your independent variable comes before your dependent variable because your dependent variable depends on the independent one. Okay? So correspondence just means relationship. So a relation is a relationship between two sets. The independent set and the dependent set. The set where we input something and then the set where they output based on what we put in. Okay? In a relation, each element from the domain corresponds to one element from the range. There are many ways to express a relation. A relation can be expressed verbally, numerically, using a table of numbers or a set of ordered pairs, or it can be expressed graphically by plotting the points, x, y, right? Because x, y is just like the point x comma y, okay? A relation can also be represented as a mapping by drawing an arrow from an element in the domain to the corresponding element in the range. Good? Okay, so if we had, for example, this is a mapping, okay? This would be a mapping. My x values are my time, my y values are my height. So I see that 0, 20, 1, 19.2, you can see what they are mapped to, okay? If I wanted to change the mapping into a, what? Verbally just means I'm saying it, I'm telling a story. After 1 second, I moved 19.2 meters up. After 5 seconds, I moved 0 meters up. That would be the verbal expression. I guess I don't know what this mapping is of. Numerically is a table of relations. So numerically would look more like an XY table. You can call it XY, or here we could call it a TH table because we have time and height. T is on the X side, H is on the Y side, input, output. I input 0 seconds, I get 20 meters. I input 1 second, I get 19.2 meters. I can see down here that I input 5 seconds and I get 0 meters, I think. All right, so that's a table of numbers. A set of ordered pairs is taking that table of numbers and turning them into X, Y. And then, right, So once you have that, you can start graphing those, and then that would be a graph. We would plot the point 0, 20. We would then plot the point 5, 0. Okay, you don't have to connect them. We're just plotting data points. An equation, on the other hand, is a line because it's an infinite number of data points. So every point connects to every other answer. There are infinite number of answers to an equation. And that's why it's a line instead of just points. Good. So numerically would be a table, set of ordered pairs is just your x, y. The graph would be graphing those x, y's. The map is a list, and then you literally draw an arrow to a different list, to the part that corresponds from the different list, okay? Sorry, here they say it better. Draw an arrow from an element in the domain to the corresponding element in the range. Good? All right. A function. A function is a relation where each element of the domain is paired with only one unique element of the range. So here are all of our, just to get a visual on it, we just talked about relations, right? Everything in this box is a relation. It's a relationship. They have something in common. From X, I can find a Y, okay? Within all relations are functions. Right? So like we have shapes. And then within shapes, we have circles. All circles are shapes, all shapes are not circles. All functions are relations, not all relations are functions. Good? Okay. A function is a relation in which each element of the domain is paired with only one unique element of the range. No, this is important, okay? No x value can be paired with more than one y value. It's okay if a y value has more than one x, but an x cannot have more than one y. When I put something into the function, if I put an x into the function, that x always gives me the same y. There are not two different y's that are possible, okay? The x is the independent variable. It can be assigned any number in the domain. Remember, our domains must exclude a 0 in the denominator and a negative under an even square root, okay? Those are exceptions to the domain, but besides that, x can be anything. And then the dependent variable is y, and once you put in an x, your function gives you a y. I don't know if I saved that page of our notes or not. Yes, once you input an x into the function, you output a y, okay? We decide what x is, the function determines what the answer to y is, right? So no x value can be paired with more than one y value. The value of y depends on x, okay? Two examples. Here's just two sets of ordered pairs, okay? This is the set 0, 5, 2, 1, 2, 6, okay? And then here is the set 1, 3, 6, 0, negative 5, 3. Yeah? Those are both relations, okay? So here's set 1. Here's set 2. They are both relations because a relation just means there's a relationship between x and y, right? We can also write this as we can write this one as 1, 3, 6, 0, negative 5, 3, right? You can also write it as a mapping where we draw arrows, okay? They're both relations, relation, relation. Which one is a function? Only one of them is a function, okay? No x value can be paired with more than one y value. So here's my x, y, x, y, x, y. I cannot have an x paired with more than one y. 0, 2, 2. 0, 5, okay. 2, 1, and 2, 6 means that this is not a function. if I mapped this, the number 2 would map to the number 1. The number 2 would also map to the number 6. This makes it not a function. Let's look at set 2. 1, 3, 6, 0, negative 5, 3. What would that mapping look like? We have a 1, we have a 6, and a negative 5. And then we only have a 3 and a 0 over here. So 1, 3, 6, 0, negative 5, 3. That is a function. I don't think we want is. Because I don't have to say is not. This is a function. Negative 5 can map to 3, and positive 1 can map to 3. The problem that makes it not a function is when 2 maps to both 1 and 6. So this x has more than one y. 1x more than 1 y, not a function. 2, we'll say more than 1x. One y is a function, okay? They are both relations. Relation, not a function, function. Good? All right. So for example 2, for each relation, identify the domain and the range. When you hear domain, I want you to think x. When you hear range, I want you to hear y. Your y is always your dependent variable. Your x is always your independent variable. Your x is always your domain. Your y is always your range, okay? For each relation, identify the domain and the range and determine whether the relation is or is not a function, okay? So for it to be a function, let's just write it right down here. A function means each element in the first set corresponds to exactly only one element in the second set. And remember, when I say first set, I mean x. And when I say second set, I mean y. Good? Each element in x corresponds to one element in y. Not a function would mean each element in the first set does not correspond to only or exactly one element in the second set. So when we map 1, 2, 3, wasn't sure. 1, this x having 2 y's, not a function. This y having 2 x's, a function. Okay, so what you don't want to see on a mapping is your x value mapping to 2 different y's. This is mapping to 1y, 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 1y. So we're going to say that that is a function. Here, x has 1y, this x has 1y, this x has 1y, this x has 1y. This is also a function. It is not a function if you have any x's that have 2 or more different y's. So Aaron sometimes maps to Princeton, Aaron sometimes maps to Duke. In a list, that's suddenly going to look like E, P, E, D. E, comma, P, E, comma, D. That is not going to work. Every time I put in Aaron, I want to get the same word out. I want to get the same college out. Every time I put in Aaron, I want to get Princeton. If sometimes I put in Aaron and I get Princeton, sometimes I put in Aaron and I get Duke, that is not a function. Okay, let's go back and look at that cute little, what would this be? This would be a function. I put in E. I want to get out the same school every time. Aaron, you're always going to Princeton. I put in Aaron, she's going to Princeton. I put in Aaron, she's going to Princeton. Oh, I put in Aaron, she's going to Duke. That's no longer a function because I cannot reliably know what is going to happen to my x. I should put in, right? If I put in 3, I want to get out -9. I put in 3, I get out 1. I put in -2, I get out -9. That's what makes it a function. This is not a function because Erin has 2 different outputs. She is 1 input. Sometimes she outputs Princeton, sometimes she outputs Duke. Is that all they asked us? Okay, identify the domain and the range. So the domain is, okay, let's do that. So for 1, my domain is just the list: beef taco, chicken taco, shrimp taco, quesadilla, nachos. And then my range is 2.5, 4, and 5.5. So they're just asking you to make a list of everything that the domain could be. The domain is all of these, and everything the range could be. So here, my domain is Gabriella, Oscar, Steve, Amanda. My range is 4610, 8986, 9178, 9908. Good. Here, my domain is Aaron, Christina, Anton, and George. My range is Princeton, Duke, Stanford, Massachusetts Institute of Technology. Example 3 asks us, for each relation, state the domain and the range and determine whether the relation is a function. So same thing. Instead of a mapping, now we just have ordered pairs, okay? Remember that domain is, I wanted to keep it with like the same color. My domain is my x, my range is my y. I should have been able to see that through the paper, right? Okay, so same thing we did with those student names or pizzas, pizza, Mexican food, and colleges and prices and steps. Our domain is going to be the set of 1, 3, 5, and 9 for this guy. Here the domain is our x values, right? So our domain is 2, 5, 7, and 1. Here our domain is -5, -2, 3, 2. I'm not going to write -5 twice. You don't need to. Okay. And then my range is going to be my y values. Domain is x, range is y. D comes before R, X comes before Y in the alphabet. 5, 9, 1, and 2. Here my range are my Y values, 6, 5, and 15. I'm going to skip that second 5. There are 2 5s, but I'm not going to write it twice. And here my range is 1, 2, 3, -2, and -3. In a bad grand finale. Okay. Is it a function? Remember, a function means every x only gets one y. Aaron only gets to go to Princeton. Aaron doesn't sometimes go to Princeton, sometimes go to Duke. Okay? So here, let's just look. We have 1, 3, 5, and 9. So that is a function. If I don't even have any x's repeating, there's no way that the x is going to be mapped to 2 different things because there's only one x. 2, 5, 7, and 1. Again, no possibility. Function. No possibility that the x can get two different y's because there's only one of each x. Let's look at this one since it's our last one. It might be different. -5, -2, 3, 2, and -5. Okay. Here we have -5, -3. Here we have -5, 1. So in my mapping, -5, I put -5 into my function. Sometimes it gives me a 1. Sometimes it gives me a -3. That is a problem. That is not a function. A function is super regular. -5 is always 1, or -5 is always -3. It can't be sometimes I put in -5, I get 1. Sometimes I put in -5, I get -3. Okay? Let's just discuss real quick the difference. Here, it's okay that every time I put in 5, I get 5, and every time I put in 7, I also get 5. That's okay. That still is a function. That's still a machine. The machine, when I put in 7, gives me 5. The machine, when I put in 5, it gives me 5. Very different from when I put in -5. Sometimes it gives me 1. Sometimes it gives me -3. So it's okay to put in 5 and get 5, and then put in 7 and get 5, and then put in 10 and get 5, and then put in -100 and get 5. That's fine. It's just that every time I put in -100, I want to get the same output. Okay? That's the difference between the x and the y. On a graph, first of all, please add an arrow everywhere. Okay? Add arrows to all 3 of those. I didn't know how in Adobe. Tell whether the relation is a function. State the domain and range using interval notation. A relation is a function when you have the graph of it if it passes the vertical line test. So grab a vertical line and just start drawing. Grab a straight edge and just start drawing vertical lines along your graph of the function. And if ever you can see a place where if I were to draw a vertical line, it would touch the graph in more than one place, that is not a function. So this is a function. Okay? This is a function because everywhere that I touch it, it's only going to cross, my vertical line only crosses my function or my equation of the line in one spot. However, down here, those are 2 spots. So this is not a function. This is a function. And here, not a function. Oops, I'm sorry, you couldn't see that. So here, when I draw a vertical line here, I touch here and I touch here. When I draw a vertical line here, I touch here and I touch here. These are not functions. I will never find a place where a vertical line will touch this line in 2 different places. So it is a function, it is a function. Let's talk about this, okay? If I was to take this point and this point, right? This point is x is 0, y is -2. And then this point is x is still 0, but now y is -4. Do you see how that presents a problem with it being a function? Every time I put in 0, I want to see -2. Sometimes I put in and I get -2. Sometimes I put in 0, I get -4. That's why the vertical line test tells you whether or not it's a function. For a function, every x should only have 1 y. Here, we have 2 y's for this x. Here, this is x equals, that's 5, 6, 7, 8. Here's x equals 8. So we have when x is 8, y is 0, and when x is 8, y is -6. You see that? So there are several places on the graph where you can get 2 different y values for the same x. Same here. So this is -4 on my x, but it's at the same time 4 on my y, and then down here, -4 is 2 on my, 2 on my y. Okay, so that's why the vertical line test works, to tell you, is it a function or not? We should never have an x with 2 different y's or more than 2 different y's. Good? All right, let's talk about domain and range. Remember, domain are our x values. What is range? Range is our y values. So where is it? And they're asking for interval notation. In interval notation, so that's going to look like this or like this on the x or the y-axis, okay? State the domain and the range. The domain is my x values. What would be the easiest place to start? The easiest place to start might be with this one and then this one. So on my x-axis, from my negative x-axis to the positive x-axis, what is included? They have arrows. That means forever in this fashion. This means forever in this fashion. So my domain on the x-axis, all real numbers. Okay, so my domain is from negative infinity, because of that arrow, up to infinity. My range is my y-axis. So from negative y, I know I drew it wrong. From negative y to positive y, I started coloring it positive while I said negative. From negative y to positive y, we are going, because of that arrow, that means negative infinity. And then because of that arrow, that means positive infinity. So on the y-axis, from negative infinity to infinity is the range, okay? Now let's look at this circle, and you know what we can do? That will be very helpful, is we're just going to box out this circle. And you can't really do it while you're on MyMathLab, but you know, like hold it up to the screen. So here are the limits of my circle. These are my limits because there are no arrows. I can see where things end, right? So this, let's just start here. This is the line x equals 2. Do we agree? Here is the line x equals negative 6, right? Here is the line y equals 4. And then here is the line y equals, I don't know, I think it's 2. I think I'm not getting very close. I think it's 2. 1, 2. Y equals 2. It's hard to tell. Okay, it's either 1 or 2. So where on, so if it's arrows, up here it was arrows. So on the x-axis, it was forever in both directions, negative infinity to positive infinity. Here though, we have from on our x-axis, from x equals negative 6 and including, sorry, let's start with parentheses for no reason. So from negative 6 until 2 only. It's going to touch it's going to touch positive 2 and it's going to touch negative 6, but it's not going to go past that. There is, this graph goes forever. This graph does not exist outside of between negative 6 and 2 on the x-axis because domain is the x. Y is our range. So now let's look at from bottom to top on the y-axis. Remember, this is our y-axis. Our graph only exists here. This is our x-axis. Our x-axis, the graph only exists from negative 6 to 2. Y-axis, I think it's from 4, 3, 2, 1. What did I say? 2? From 2 to 4. It should be clearer on yours. But do you see that? So I just boxed it in, and then so on the x-axis, my graph exists from negative 6 to 2. On the y-axis, from either 2 or 1 until 4. Okay? Let's look at this guy. This guy, and you can do the same thing, okay? X, my domain is x. So my x starts at this line, okay? That is the line x equals negative 1. And then it goes, because of this arrow, it goes forever to positive infinity, okay? So I'm going to graph that as negative 1 but it goes forever in the other direction because of that arrow and that arrow. All right. For the range, we are talking about the y-axis. Where does it go on the y-axis? This arrow is going in the positive y direction. This arrow, though slowly, is going in the negative y direction. So for my range, I'm going to say that's never going to stop going like that. So it's going down to negative infinity. That's never going to stop going up. So I'm going to say infinity. Okay, let's look at our last one. Domain for x values. My x value is along the x-axis. This is an arrow. That arrow is, though slowly, it is moving in the negative x direction, all right? So from negative infinity, that arrow is moving in the positive infinity direction and will never stop for x, okay? But it's a different story for y. What's the story for y? The story for y is that from 5 and below, okay? It's not negative infinity to infinity on the y because it never goes above y equals 5. So we can start at negative infinity because that arrow is going towards negative infinity on the y. That arrow is going towards negative infinity on the y, but it's going to end at positive 5 and never go above positive 5. So that's how you find the domain and range of something that has been graphed, an equation that has been graphed, and how to write the domain and range in interval notation, which is very challenging, but hopefully we've had some practice. Okay, example 4 asks us to determine whether the equations define y as a function of x. Hold on one second. All right, so our next task is to determine whether the equations define y as a function of x, okay? Basically, for something to be a function, it needs to be unique. What needs to be unique is that there is only one y for every x. So if y is defined as a function of x, that means y is unique, okay? What do? We solve each of these for y, and that will tell us, does each x value yield only one possible y value? If you see something like y equals plus or minus x, that means there are two answers, right? There's a positive x and there's a negative x. Y squared equals, that means there's going to be two because we're going to have to take the square root, and when we take the square root, we add a plus and a minus, okay? So those are like your red flags. If you see a plus or a minus, or you see a y squared. X squared is okay, but y squared is not okay. We're going to solve for y, and then make sure that there are no values of x for which two values of y will result, right? So this one's already solved for y. Y equals x squared. No matter what x we put in, you can try to put in an x. Y equals 0. I'm just going to say x. 0 is not good. Y equals, if x is 1, 1 squared, y equals 1. So that is defined as a function of x, right? We take x, we multiply it by itself. For any number, this series of operations, taking the number and multiplying it by itself, will only give us one y, one answer. So this is a function. This does define y as a function of x. This is a function. So you solve for y and you kind of just describe it to yourself. A number squared. Taking a number and multiplying it by itself will always give me only one answer. All right, now we have x minus 9y equals 3. Solve it for y. Let's move the x, divide by 9, and don't worry, you're not going to have to do anything, right? We're just going to look at it. Ooh, divide by negative 9, sorry. So y equals negative x plus 3 divided by negative 9. Don't worry about what that means, but let's think about it. I'm going to take a number, I'm going to make it the negative of itself, so I'm going to take the negative of that number, I'm going to add 3 to it, and then I'm divided by negative 9. No matter what x I put in, it's only going to give me one answer to that x. If I put in a 1, negative 1 plus 3 divided by negative 9 is always going to give me 2 over negative 9. There's no way for me to get two y's out of that. So that is a function. Let's look at x squared minus 3y squared equals 1. Now you might be wondering, can I just say that this is not a function? Sure. If we had to solve it, we're going to solve for y, so we're going to move the x over. Negative 3y squared equals negative x squared plus 1. So even though it's a negative, I would put it in front of the 1. Divide by a negative 3. Divide by a negative 3. Y squared equals negative x squared plus 1 over negative 3. Don't worry, we're not going to do anything with this, okay? But there is a final step to solve for y, right? Take the square root of y squared to get rid of the squared. Take the square root. When we take the square root, we're going to include the plus and the minus. So now we have y equals plus or minus square root of negative x squared plus 1 over negative 3. Because I now have the positive of that answer and the negative of that answer, I know that those are two different y's I will get when I put in an x, right? So that is not a function. We can also try it. We can say x squared. So if I put in a 0 here, right? 0 plus 1 divided by negative 3 and taking the square root of it, I'm still going to get the positive square root of that answer and the negative square root of that answer. Okay, that is not a function. Now here we have y equals 5x squared minus 6x plus 6. That is a function, right? No matter what x I put in, if I put in a 1, 5 times 1 is 5, minus 6 times 1 is 6, plus 6, that's always going to give me 5. So it is okay if your x is squared. It's okay if you have a fraction. What's not okay is a y squared, because a y squared is ultimately going to give you, a plus and a minus, and that's going to be the problem. All right? The plus and minus tells us that there are two values of x, there are values of x for which the two values of y will result. Okay? So here's just a little picture of function notation. If an equation represents a function, then y is a function of x, and we can write y equals f of x instead of y, okay? Y equals 2x minus 5, if it's a function, can be written using the function notation f of x equals 2x minus 5. F of x equals 2x minus 5. F of 3 means I'm changing x to 3. F of 3 means that now, for 2x minus 5, x equals 3. What is y? Okay? So when f of x equals 2x minus 5, f of 3 means x equals 3, is 2 times 3 minus 5. 2 times 3 is 6 minus 5, which is 1. So we say f of 3 is 1. X is 3. When x is 3, y is 1. So we can also write it as the point 3, or ordered pair 3, 1. So when you see f of 3 equals 1, that means your x is equal to 3, your y is equal to 1. Same equation, f of x equals 2x minus 5, but now they're saying, what is f of negative 2? F of negative 2 means I'm going to replace x with negative 2. 2 times negative 2 minus 5. 2 times negative 2 is a negative 4 minus 5, negative 9. So f of negative 2 is equal to negative 9. It's the point negative 2, negative 9, because when x equals negative 2, y equals negative 9, right? So I input my x into my function, and I output my f of x, or I output my y. I input 3, it outputs 1. I input negative 2, it outputs negative 9. I input negative 2, it outputs negative 9. Okay? Don't worry, you will have time to get used to it. All right, for the function f of x equals 2x squared minus 5x, evaluate the following. So let's just practice. F of 2 means that x is now equal to 2. So we're going to say 2 times 2 squared minus 5 times 2, right? I should probably move this all down. All right, A was f of 2 is equal to 2 times 2 squared minus 5 times 2. So that's now 2 times 4 minus 5 times 2 is 10, right? So we have 8 minus 10, which is negative 2. So how I'm going to write this is f of 2 is equal to negative 2. Okay? B f of x plus f of 2. F of x was 2x squared minus 5x, and f of 2, we already did it, was negative 2. F of x was 2x squared minus 5x plus f of 2, but f of 2 was a negative 2, so you could say plus negative 2 or just minus 2. See? 2 times f of x. That's not saying that we're replacing x with 2. That would be that one. That one we replaced x with a 2. 2f of x means we're going to take a 2 and put it outside of f of x. F of x is still 2x squared minus 5x. But we're going to distribute a 2 to both the 2x squared and the negative 5x. 2 times 2 is 4x squared, and then 2 times a negative 5 is a negative 10x. Good? So that's 2f of x. D asks for f of negative x. All we're going to do is take that 2 times x squared and make it a negative x squared minus 5 times negative x. A negative x squared is just a negative x times a negative x. Negative 5 times a negative x is a positive 5x. So that's just negative times a negative is positive. 2x squared plus 5x. Oops, sorry. E, instead of making the x negative, we're making the entire function negative. So a negative f of x means we take a negative, and instead of distributing a 2 to the 2x squared minus 5x, we're taking a negative and distributing it through the 2x squared minus 5x. Negative 2x squared, negative times a negative 5x is a positive 5x. F of 2x means that everywhere that there's x, I'm going to put in a 2x. Sorry, f of 2 just meant I put in a 2. F of negative x meant I put in a negative x, but f of 2x just means I put in a 2x. So I have a 2 times 2x squared minus 5 times 2x. Good? So, since this is the last one, I might just go straight down. 2x squared means 2x times 2x. Negative 5 times 2x is a negative 10x. 2 times 2x times 2x. 2 times 2 is 4. X times x is x squared. 2 times 4 is 8. So my final answer is 8x squared minus 10x. Good? Okay, we've got one more thing to do. We are going to talk about the domain of a function. Oh my gosh, we have 2 more things to do. All right, we're going to talk about the domain of a function. The domain of a function is the set of possible replacements or inputs for variables. So the domain is all real numbers. Exclude from the domain any time the denominator would equal 0, or there is a negative number under an even radical. The radical of an even index would be greater than or equal to 0. That's that one. And the denominator would equal 0. That's that one. Okay? So if you don't have a fraction and you don't have a radical, an even root right here, you don't need to worry, okay? So this one, we're just gonna say it's all real numbers. Domain is all real numbers, okay? B, we have a number under the denominator. You get those confused. It's not under the radical, it's under the denominator. What you want to do when you have a number under the denominator is you take that number, x squared minus 25, and you set it equal to 0, and then you eliminate from your domain anything that when you solve it for x, you eliminate those numbers from the domain, or that number. So add 25, x squared is 25. When I have to take the square root of x squared, on this side I'm going to say plus or minus, right? So then that is x is equal to, the square root of 25 is 5, but it's going to be -5 and +5, right? Because the square root of 25 is 5, but we have the plus and the minus because it's the square root. So our domain is x such that x cannot be -5 or 5. Good? Here, we have the square root of 5 minus 5t. If it's a square root, we want to make sure it can't be negative. So to solve this, the radical of an even index must be greater than or equal to 0. Okay, and then just solve that. So we're going to subtract 5, -5t is greater than or equal to -5, divide by -5, divide by -5. When you divide by a negative, you need to flip your sign. -5t divided by -5 is a 1. -5 divided by is a 1t. And then -5 divided by -5 is a 1. So it's t is less than or equal to 1. So my domain is, we would say t such that t is less than or equal to 1. Good? Here we have both a number or an x in our denominator and an x under a radical. So for this one, we want to take this one and set it equal to 0, just like we took that bottom and set it equal to 0. X is 2, so we're eliminating x equals 2, but we also need to take this part and set it greater than or equal to 0, just like we did with the 5 minus 5t. So I'll subtract 6. 2x is greater than or equal to -6. Divide by 2, divide by 2. X is greater than or equal to -3. You don't change the sign if that one's negative, only if the one you're dividing by is negative. Good? So here, it's a hard one, but the domain is x such that x is greater than or equal to -3. X cannot be 2. Good? If x were 2, it would make a number in the denominator, and that would be undefined. And then if we had it less than -3, then we would have a negative number under the radical, which would be an imaginary number, okay? I'm going to do 3 more examples, but feel free to fast forward if you feel comfortable. So this one is f of x is equal to x over x squared plus 19. Obviously, what we're worried about is the x squared. Oh no, my sweater is now green. What we are worried about is the x squared plus 19. We don't want that to equal 0. Okay, so we're going to subtract 19, x squared equals -19. Take the square root and plus or minus, but the square root of a negative number, no solution. So this one's okay. We're not talking about imaginary numbers, right? We're trying to prevent this. And in trying to solve for x, we found it. So there is no number that I can square and add 19 to it and get a 0, right? So this is all real numbers. Here we have f of x is equal to the square root of 2x plus 10, right? We don't want that to be a negative number, so we're going to say 2x plus 10 is greater than or equal to 0 is the rule. Subtract 10. 2x is greater than or equal to negative 10. Divide by 2. Divide by 2. X is greater than or equal to negative 5. So my domain, x such that x is greater than or equal to 5. Negative 5, sorry. And then here we have f of x is equal to the square root of 25 minus x. Good. We don't want that to become a negative number, so that is greater than or equal to 0. Subtract 25. Ooh, you know what would be easier than subtracting 25? Let's add x. Add x, add x. 25 is greater than or equal to x, right? So my domain is x such that x, I'm going to flip it, is less than or equal to 25. If it's more than 25, then you'll be subtracting 30 and you'll get a negative number. All right, so that's how we're dealing with domain. It's a lot, and we'll keep reviewing it after this lesson. It will show up again. All right, this is combining two functions and determining the domain, okay? So we have two functions. F of x is equal to x minus 1, and g of x is equal to 2x squared. A says, what is f plus g of x? That just means we are adding f of x and g of x. X minus 1 plus 2x squared becomes 2x squared plus x minus 1. Okay? B, f minus g of x is equal to x minus 1, you don't really need the parentheses, but minus 2x squared, you don't need those parentheses either, equals negative 2x squared plus x minus 1. Good. C, f times g of x is x minus 1, now you need the parentheses, times 2x squared. I'm going to distribute the 2x squared to the x minus 1. 2x squared times x is 2x cubed, and then 2x squared times negative 1 is a negative 2x squared. Good. And then D is asking us to divide them. So f over g of x is equal to x minus 1 over 2x squared. Good. All right. Ooh, and then they want us to determine the domain. Sorry. Okay, so find the following functions. That's the new function when you add those two functions. That's the new function when you subtract those two functions. That's the function when you multiply the two functions times each other. And here's the function when you divide it. This domain is all real numbers. This domain is all real numbers. This one is also all real numbers. Because remember, we don't care about anything unless there is a number or a variable in a denominator or a variable under a radical, an even root. Okay, so here we have 2x squared cannot be 0. So we solve it for 0 and we eliminate that answer. Divide by 2, divide by 2. X squared equals 0 divided by 2 is still 0. The square root of x squared and the square root of 0. So now it's x equals 0. So this domain is x such that x cannot be the number 0. And if we think about it, 0 squared times 2 is going to give us 0 in the denominator. Good? All right, I know that was a long one. Hopefully it came together okay, and your practice goes okay. And this is the first lesson of the unit, but the unit's going to slow down, and we are going to continue to apply this in various ways. Thanks so much for watching.